Okay, in today's lesson we're going to be looking at graphs for inverse variation functions, specifically when we're looking at y equals k divided by x and y equals k divided by x squared. But before we do so, I want to look at what one of these graphs might appear to be when we go to graph it. So, because we're familiar with parabolas is what we talked about in the previous lesson. But in this one, like I said, we're going to be looking at a couple of new types of graphs that you haven't seen before. So first off, let's just see how we would graph them. We want to graph an equation in the form y equals k divided by x. Let's say if we wanted to graph an equation like 6 divided by x. The way that we do that, again, we don't change anything to the left of this equal sign. We leave that the way it is. So if we wanted to graph 6 divided by x, we just hit enter, and there we go. That's what the graph of y equals k divided by x would look like. And we have a name for that. This shape of a graph is called a hyperbola. Now, some things to notice about the hyperbola here, and in fact, any hyperbola we graph would have the same properties. For example, if I put another one up here, let's put a bunch up here. So you can see that all these hyperbolas have some similar properties here. They all are in quadrants 1 and 3. You want to make sure again that you have these quadrants memorized, because this is going to be true for any hyperbola in the form y equals k divided by x. So this would be quadrant 1. Remember, we go counterclockwise, so quadrant 2, quadrant 3, and quadrant 4. Some other things to recognize is the domain and range. If you notice, the domain goes, for this graph here, let's look at the one in blue, the first one I did, goes infinitely in the positive direction, but as it comes back this way, it's like it bends away from the y-axis. And as we go in the negative direction, it goes infinitely in the negative direction, but as we come back this way, again, it bends at the y-axis. Well, the y-axis is where x is equal to 0. So what's happening is this graph, as it gets closer to where x is 0, it's veering away, and I would call that an asymptote, meaning that this blue line, the green line, the red line, the purple line, none of these graphs are ever going to touch the y-axis, where x is equal to 0. So we'd say the domain is going to be all real numbers except 0. And we'll look at writing this down here in our notes in a second, but I just want us to look at the graph as we talk about some of these things. Now, if I were to change these graphs to be where y is negative, so where y equals negative 6x, so my y equals 6x was this blue graph here, but as soon as I made it y equals negative 6x, watch what happened. It flipped. Remember, we've talked about that. When we have direct variation, a straight line goes through quadrants 1 and 3. And when k was negative, made it go through quadrants 2 and 4. Yes, or in the previous lesson, we were looking at parabolas. Y equals kx squared gave us a parabola that was in quadrants 1 and 2. As soon as we made it negative, it flipped. And so it was down here in quadrants 3 and 4. So whenever k is negative, whenever we have a negative value for k, it causes our graph to flip quadrants. That's important to remember. Okay, let's get this stuff in our notes. So you may want to pause this video if you have my notes, or if you don't have my notes, you want to make sure that you get all of this written down. Actually, if you don't have my notes, it might even be better just to draw this graph down here, which we'll get to in a second. But hitting on some key things here, whenever we have an equation in that form, y equals k divided by x, and again, k can't be equal to 0, otherwise it's not going to be a hyperbola, it's not going to be graphable. All of these would be hyperbolas, as I've already mentioned. Doesn't matter what k is, but the way the domain and range will always be this whenever we're looking at a hyperbola. Whether k is positive or negative, the domain would be all real numbers except 0, and the range would be all real numbers except 0. Now if that helps writing it out in words because you know exactly how to write it and explain it in words, that's fine. Or if you want to write it in symbols, you can have what I have in brackets over here, because what this would mean is that this is the set of all x's where such that x doesn't equal 0. Now when we look at a graph, the two parts of the line are broken up, so we call those branches. And again, when k is positive, the branches are in 1 and 3. If k is negative, it's in quadrants 2 and 4. Now something that will help you remember as far as what quadrants it's in, something that's helped me out, is that if you think about a graph in the form y equals k times x when k is positive, we had a straight line that was in quadrants 1 and 3. Well, k divided by x takes and breaks that up, because dividing means to break up. So as you can already see in the graph on the left, I'll just show you again over here, side by side, when k is greater than 0, it takes this graph that was a straight line and breaks it up into two pieces, but those graphs, those lines are still, those pieces are still in quadrants 1 and 3. So that's something that maybe will help you out as we go through this chapter. And again, make sure that you have this information down. You'll want to have, if you don't have my notes and you're writing this down in your own notebook, you want to make sure that you have this graph laid out, because this pretty much describes everything what we just talked about in the paragraph above. And you also, it's really important to get this term written down, an asymptote. An asymptote is an imaginary line. It's not a line that we actually graph. Now granted, you see the asymptotes in this case because the asymptotes are the x and y axis, but an asymptote is where basically a line will never touch it. I like to think of it as it's like an invisible fence for a dog. Okay, a dog knows exactly how far it can go. It can get really close to that invisible fence without getting shocked, but as soon as it touches that invisible fence, it's going to get zapped. And so it can get really close to it, but it'll never want to cross it. That's what a line does with an asymptote. It'll get really close to it, but it'll never ever cross it. And by the way, when we say it's got a vertical asymptote at x equals 0, now you might recognize that's the same as the y-axis. But the reason why we say that x equals 0 is not a point. X equals 0 is a line going through, I'll write it this way, where x equals 0, if that makes sense. Because sometimes we're going to have other asymptotes in future chapters, or maybe the asymptote is x equals -2, meaning that it's a vertical line going through the point where x would be -2. And that would be the asymptote. Obviously not in this case, but it's important to understand that x equals 0 is not a point. It's referring to a line going through the point where x is 0. Specifically, the y-axis in this case. The same thing with the horizontal asymptote. When it says a horizontal asymptote at y equals 0, that's referring to the x-axis. Okay, we can have a horizontal asymptote here. And again, that's where y equals 0. So you want to make sure that you understand that, because you will have questions about that on the test and on even the future quiz. Okay, so again, to review this front page of our notes, we're talking about hyperbolas, and they're in the form y equals k divided by x. Now what if it was in the form y equals k divided by x squared? Let's go back to our graph. We're going to graph 24 divided by x squared. Now it says in a window where x goes from -5 to 5 and y goes from -10 to 10. I'm going to show you first how to change our window settings, so that way we can see the whole picture that they want us to be looking at. So whenever you see in your assignment something written like this, we want to change the window settings. So if I'm going to change the window settings, I want to go to, well, first I'm going to go to a new graph. Again, make sure you're not going to Scratchpad. Make sure you're going to that icon on the bottom of your screen. Okay, so now to change the window settings, I'm going to go to Menu. Number 4 says Window Zoom. And the very first thing it says is Windows Settings. Now I want to change my X minimum to be -5. So you just tab to go to the next one, and you can type in then I want your maximum to be 5. Sometimes our graph counts by some different units, so this allows us to change the scale, or we can have the calculator automatically select our scale. I want to make sure it does something where I can easily see my different values on my x-axis, so I'm going to have it count by ones. Our y minimum says we want it to go from -10 to 10, so our y minimum is going to be -10. Tab down. Our y maximum will be a +10. You can tab down again, change your y scale to be 1, tab down again, and hit enter. So now you can see we have it going from -5 to 5, and from 10. We can't see -10 right now, but we will in a second. Now I want to put in our graph. Our graph is going to be 24 divided by x squared. Okay, so if you notice, this graph, 24 divided by x squared, is kind of like a hyperbola, except for we have one branch in quadrant 1, and the other branch is in quadrant 2 instead of down here in quadrant 3. What if we were to graph where k is negative? You can probably guess what's going to happen. But let's see, if you hit tab, you can type in now -24 divided by x squared. And enter. And again, just like we've seen in all of our other graphs, having a big negative value for k causes our graph to flip. So instead of being in quadrants 1 and 2, it's now down here in quadrants 3 and 4. Your notes will ask you where is the graph symmetrical to. So if you look at this red graph, the first one that we did, that's symmetrical to the y-axis, or where x is equal to 0. This is not the reason why we would say that it's symmetrical to the y-axis is because what they're asking us for is if we were to flip this over an imaginary line, so in that way the graph would lie on top of itself. It would be the y-axis that we would flip it over, so in that way the two parts, the two branches, would lie on top of itself. But you could also say that it has an asymptote, just like the other graphs did. This has a horizontal asymptote down here along the x-axis where y is 0. It has a vertical asymptote along the y-axis, or where x equals 0. Okay, so let's go back to our notes. So they just want us to draw a sketch of what each graph looked like. Something like this. For y equals k divided, or 24 divided by x squared, our second graph looked more like this. Okay, now an easy way to remember the quadrants that it's in, if you remember that y equals k times x squared was a parabola. That was in quadrants 1 and 2. If I have k divided by x squared, like in this first graph, it's still in quadrants 1 and 2, but what it's done is it's taken that parabola and broken apart in two branches. So whenever you have an x squared, the graph is going to be in quadrants 1 and 2, as long as k is positive. Whether that's a parabola. Now what we call this graph has a special name. This graph is an inverse square curve. Okay, you want to make sure that you get that written down in your notes. So we have an inverse square curve and a hyperbola that we've talked about today. We're going to skip this. I want to get to the end down here. So again, with y equals k divided by x and y equals k divided by x squared, they both have the same vertical and horizontal asymptotes. That's important to make sure you get in your notes. And the last thing that I forgot to type into the notes, but you want to make sure you get this definition down, is this term discrete. When a graph is discrete, that means it's a set of points that are not going to be connected with a line. This often happens with story problems. It also happens with sequences. Remember when we graph sequences, we said that we would graph those points, but we would not connect them with a straight line because the domain is not the set of all real numbers. It's just a set of integers. So with a sequence, we only use numbers like 1, 2, 3, 4, and so on. We don't use decimals. By connecting points with a line, that means that you're including all the points between the two you have graphed. So it means that it would include the decimals. So that's it, and good luck.